Hey everyone, welcome to homework video 1.13b. I'm going to start by going over the homework and then I'll go back into the classwork to go over the classwork in case you needed some assistance with it. So for the homework, the first few questions, 1 through 3, are giving you what one of them equals, right? So all you need to do is substitute this and solve for y. So if I substitute, remember I told you in class today, put parentheses around the thing that you're going to use, and then substitute, right? Put your parentheses around where you're substituting that, so you know this is where that's going. So this is going to be 5 plus y equals 12. Now I can solve for y. I can subtract 5 from both sides, and we get y equals 7. And so now I know that my point is 5, 7. That's the solution. Same thing, parentheses around this one, it's x, so I'm going to put that there. Negative 2 plus 3y equals 4. I'm going to add 2 to both sides, and we will get 3y equals 6. Divide both sides by 3, y equals 2. Okay, so now we have negative 2, 2 as one of our points. All right, so number 3, now that you've seen that, you can do that. Plug it in for y, and then solve for x, and then you have your answer, you have your solution. Let's take a look at number 4. I'm going to show you basically one example from each row. So if we have y equals 2x, we're going to substitute that in here for y, so we get x plus 2x equals 9. We can combine like terms, so 3x equals 9. And then I'm going to do inverse operations and divide both sides by 3. We get x equals 3. So now I have x. I need to then take this and substitute it to find out what y is. 2 times x, or 2 times 3, is 6. So that means y equals 6. That is our solution, 3, 6. Okay. I'll show you actually number 5 just because there's a negative here. So if we're putting that in as substituted here, it'd be x plus negative 3x equals 4. This is important because we have a negative 3x, and you got to keep that negative with our term. And so negative 3x plus 1x is negative 2x equals 4. Now I can divide both sides by negative 2, and we get x equals negative 2. I can plug that back in up here, and I'll get y equals 6. So you should have negative 2, 6. Oh gosh, sorry you all. I forgot to turn off my notifications, so getting lots of text messages. Let me go ahead and put on Do Not Disturb. All right, so that's those examples. You can do this. So same thing here, plug in, instead of x, you're going to plug in 3y. See what you get, okay? Now, actually, for number 6, I do want to review that this is a special situation, okay? So put a star here because this is a very unique situation. If I'm plugging 3x in here, or 3y rather, let me fix that. I'm plugging in 3y for x minus 3y equals 0. I end up with 3y minus 3y is 0. So 0 equals 0. Ooh, what does that mean? Well, what's interesting about this, if you end up with something equals something, and it's true in a system of equations, that means that there are infinite solutions, and this is actually the same line. Okay, so just as an example, if I were to solve this for y the way that I would to graph it, I would make this y equals 1/3 x, right? And then here as well, if I were to do x minus 3y equals 0, and I were to move the 3y to the other side, x equals 3y, notice they're the same equation. That's the same as this equation. And that means that the lines, if we were to draw this, for example, and this is just an example, it's not what the line would actually look like. Let's say one of the, if I were to actually draw out that line, that would be one of the lines, and then the other line would be right on top of it. It would be the same exact line, and so there's infinite solutions that would make both of those true, right? If I put a number in for x and y, I will get the same thing in the other equation, all right? So that is, I'm sorry, I don't know what my tablet's doing funky things. Okay, all right, but so when you have something where one thing equals the other thing, and it is a true statement in a system of equations, that means there are infinite solutions. All right, Let's look at number 8. And then the reason I'm going to look at number 8, you guys can do number 7 and number 9 yourselves. Substitute that in here for x, substitute this in for y. For this one, be careful with your signs, be careful with those negatives. But let's look at number 8. And we're going to look at number 8. We're going to plug in 2x for y here. So I'm going to rewrite this as negative 6x plus 3 times 2x equals 16. And so I'm going to get negative 6x plus 6x equals 16, which means 0 equals 16. That is not a true statement. So this is like the opposite of number 6, in which in this case there are no real solutions. Okay? I'm going to prove it to you by showing you on the graphing calculator. We have y equals 2x as one of our equations. The other equation, if I solve for y, is negative 6x plus 3y equals 16. I'm going to add 6x to both sides. We'll get 3y equals 6x plus 16. Y then is going to equal 2x plus 16 over 3. Okay? Now, let's take a look. If I do split view and pull up my calculator. Where's my calculator? Here it is. Okay. And I go to y equals. Let's clear out our old. Oh, I'm not sure what happened there. Okay, let's clear that out. So our first equation is 2x. Our second equation is 2x plus 16 over 3. Oops. Over 3. Okay. Now notice when I graph these, what kind of lines are they? They're parallel lines, so they're running next to each other, and they will never intersect. And because they are parallel lines, they have the same slope, but different y-intercepts. They're parallel lines, it's not letting me draw it. They're parallel lines, they have the same slope, but a different intercept. Then they run next to each other, and they will never intersect, which means that we don't have ever a solution for that particular set of system of equations. Okay, so just so that you can see what that looks like. On the, nope, that's the wrong one. Oh, you can see that my children have been on here. Okay. That means that they're running next to each other. They're parallel lines. They will never cross, and so there's no solution. All right. Let's go ahead, and I'm going to just erase maybe. Whoa, things are like really going crazy on this thing today. All right. Well, you know, let's see. I think maybe the internet's slow, and that's actually what it is. All right, there we go. All right, so that one has no solution because if, unlike number 6, where if everything equals, both sides are equal and it's a true equation, true equality, then there's infinite solutions. If you have something where there's not a true statement, right, then that means that there's no solution. So in that case, we got 0 equals 16. We know that that is not true. Okay? All right. So numbers 7, 9, do on your own. You can 100% do that. Let's take a look. Here we go. Really, well, bad things are happening, you all. I'm not sure what's going on here because it's like not responding at all. Oh, there it goes. Okay. Well, these are just permanent, apparently. All right. Well, let me give you an example with number 11 anyway. So, number 11, I am looking at solving the system of equations. Now, honestly, there's a couple ways to make this easier, but let's say we're solving for x. We'll start with that just because there's only one term there. And so we're going to do x plus 3y equals 1. Now I want to solve for x, so I'm going to subtract 3y from both sides. We're going to get x equals negative 3y plus 1. Okay, so now I have my x. That's going in the parentheses, and I'm going to put this in parentheses here because that's where it's going to replace it. So I'm going to rewrite this equation as negative 3 times negative 3y plus 1 minus 3y, the rest of the equation, equals negative 15. Be careful with things like this. Make sure you include them. Now I'm going to use my distributive property to simplify this. So we get positive 9y, negative 3 times positive 1 is negative 3, minus 3y, equals negative 15. So I can combine this one with this one, so this is going to give me 6y minus 3 equals negative 15. I want to get y by itself, so I'm going to do my inverse operations and add 3 to both sides. I get 6y equals negative 12. Divide both sides by 6, y equals negative 2. So now I have the y, I need to go back and solve for x. So I have x plus 3 times negative 2, I'm replacing the y here, equals 1. X plus negative 6 equals 1. I'm going to add 6 to both sides, and so then I will end up with x equals 7. So adding 6 to both sides, we get x equals 7. So my point here is going to be 7 comma negative 2. And that's the solution to that system of equations. Okay? So that is a great example there. And again, it is still only letting me erase certain parts of this, and I don't really know why, but you know, it's just what it is. Okay. All right. Let's see. Let's go ahead and take a look at, actually, I'm just going to highlight for you. Number 13 is an interesting one. So be careful with number 13. That's the hint that I'm going to give you for that one. And then let's go ahead and take a look at number 14 here. Okay. So in 14, I can solve for x or y in either equation. All right. What I did is I went ahead and solved for y here because all I have to do is do y, minus 5x plus y equals 13. And then I went ahead and I added 5x to both sides because then we'll get y equals 5x plus 13. Nice positive numbers. All right. And so then I can take this one. And remember, I used this equation as my starting point, so I'm going to plug y equals into the other equation here for y. So now I can do negative 3x plus 3 times 5x plus 13 equals 3. Negative 3x plus 15x plus 3 times 13 is 39 equals 3. I end up with 12x equals 36. I can divide both sides by 12, and I get x equals 3. Now I can take this 3, plug it back in, and see what I get for y. So I'm going to use this equation because it's a little bit simpler. So we have negative 5 times 3 plus y equals, what is that, 13. Negative 15 plus y equals 13. And then I'm going to go ahead and, where did I do? Oh, 5. Oh, you know what, you all? I made a mistake. See? Okay. So this is right. Signs are really important. So when I did this, I made it a positive 36, but I needed to subtract 39 from both sides. That's why we don't skip steps, y'all. So it's negative 36. So this is negative 3. Okay, I knew that did not look right. So going back, right, when I needed to subtract this from both sides, I should have been subtracting 39 from both sides, and then 3 minus 39 would give me a negative 36. This then means my answer is negative, so this is going to work out better. So negative 3 times negative 3 plus 3y equals 3. I'm going to get 9 plus 3y equals 3, and subtract 9 from both sides, we get 3y equals negative 6, y equals negative 2. And then I can go ahead and plug those back into the top and make sure that they work out. If I do negative 3 times negative 3, I get positive 9. Positive 9 plus 9 times negative 2 is going to be negative 6, and that does in fact equal 3. So we know that that works out. Okay? All right, so be careful with those signs. See? This is a perfect example of why you need to do every step and show every piece of work, as I've been saying. All right. I'm actually going to show you number 19 because we're going to end up in number 19 with an interesting fraction, and I want to show you a way that you can handle that. So if my computer will comply with me, let's look at number 19. Okay. So in number 19, we are looking at a system where we have coefficients for both x and y. So there isn't one that is obviously easier to do than the other. And what's difficult about this is that whatever we divide, we're going to end up with a fraction, right? There's no like perfectly, 17 is a prime number, so it's not going to be divided nicely by anything, and we're going to have a fraction. So what I went ahead and started by doing is solving for the one that I thought would be the easiest to solve for. And so that was solving for x down here in this one. Now again, you can do whichever one you feel is easiest. I thought this was easiest because I can add 7y to both sides. So I get 2x, this cancels out, equals 7y minus 17. Divide both sides by 2. And we get x equals 7y minus 17 over 2. That's not beautiful, but I'm going to plug it into here and see what I get. Okay, so you're going to do negative 5 times 7y minus 17 over 2 minus 8y equals 17. Okay, you see why this is not the most beautiful thing in the world, right? And so what I'm going to do then is distribute my negative 5 through and get negative 35y. And then negative 5 times negative 17 is going to give me positive 85 all over 2. Don't forget the denominator. Minus 8y equals 17. Okay, so now here, before moving on, what I said to myself was like, this is really messy and I don't really like that fraction in the bottom. And so if we want to get rid of a fraction in the bottom, we can divide by that, which means multiplying by the reciprocal. So what I did to get rid of that 2 is multiply the entire thing by 2. Because what happens here is 2 divided by 2 is 1, so that will cancel out in here. But then I also have to multiply it through the rest of it. So I rewrote it as negative 35y plus 85 minus 16y equals 17. And the reason I don't need to multiply 2 by here is because I could, but then I can just divide by 2 and it's going to give me 35y plus 85. Is because this whole thing, this whole numerator is over the 2, and so I can cancel the 2's out. 2 divided by 2 is 1. But I still need to multiply the rest of the equation by 2 in order for it to stay balanced. So now this makes it a lot easier for me to deal with because I don't have that fraction in the denominator. So I can combine these two, and we're going to end up with negative 51y plus 85 equals 17. I'm going to subtract 85 from both sides, and you'll actually end up here with negative 51y equals negative 51, and therefore y equals 1. Okay, so I'm going to get you that far, and then you take that 1, plug it in here, and solve for x. Okay, see what you get for x. But I wanted to show you this example of if you end up with a fraction in your denominator, an easy way to get rid of that is to just multiply the entire thing, remember both sides, by whatever's in the denominator to help get rid of it and make it a little easier to work with. You'll still get the same answer as long as you maintain both sides as equivalent. All right, so that's it for the homework section. As you're doing the homework, if you want to check any answers, feel free to text me and ask me, did I do this right? Is this correct? And I'll be happy to look at it and tell you yes or no. But I do want you to try to grapple with these a little bit on your own. Remember, the first thing you're going to do, step 1, solve for x or y in one equation. Doesn't matter which one, but choose the one that's going to be the easiest, okay? 2, substitute for that variable that you solved for in the other. Then 3, solve for the variable, and once you get that, whatever it equals, go plug it back into one of the other equations. It doesn't matter which one. Once you have an answer, an x equals or a y equals a number, you can go ahead and go back and plug that into the original equation and see what you get for the other variable. But remember, you should have 2, right, x and y variables when you're solving these. The steps are also here today with your homework in case you forget something or you need help with it. There's an example up there at the front so that you can use that as an example. Let's roll back to the classwork. I'm going to go over numbers 7 and 8 and then the park example. All right, so for number 7, when I look at this, I see that I have a negative 3y and I have an x without a coefficient, meaning there's nothing in front of the x. And so this looks like the easiest thing for me to solve for. So I have negative 3y plus x equals 1. I'm going to add 3y to both sides. And I will end up with x equals 3y plus 1. So now this is what I'm going to go ahead and put my parentheses around, because in this equation, I'm going to substitute that. So 2 times 3y plus 1 plus 4y equals 12. And then I'm going to go ahead and distribute this 6y plus 2 plus 4y equals 12. Combine these two because they both have y, so this is 10y plus 2 equals 12. And then subtract 2 from both sides, I get 10y equals 10. Divide both sides by 10, and we get y equals 1. Now I'm not done, I need to go back up, so negative 3 times 1 plus x equals 1. Negative 3 plus x equals 1. Okay, this is the same thing as x minus 3 equals 1. So some of you have been having difficulty when the variable comes second in the expression. This can be rewritten as x minus 3 equals 1. If that helps you, then you know you're going to add 3 and we get x equals 4. Okay, so if that's something that you're struggling with because you see the variable second and that's confusing to you, you can go ahead and consider the way to move that about so that it's easier for you to see. But ultimately, this is a negative 3 that I want to get rid of, right? And I want to leave the x all by itself and isolate that x. So to do that, I'm adding 3 because negative 3 plus 3 gives me 0. And so I'm only left with an x on this side, and then I can add here and I get 4. All right, so your solution here is 4 comma 1. All right, let's look at number 8. Number 8 is very similar in that I have no coefficient of x and I have a negative coefficient for y in the first one. That one therefore looks like the easiest one for me to use. So I'm going to add y to both sides and I'll get x equals y minus 4. That's so much easier to plug in now. So I'm going to put parentheses around that, put it here where the x is, negative 2 times y minus 4, make sure you pay attention to that negative, plus 3y equals 6. Now I'm going to distribute negative 2y plus 8 plus 3y equals 6. And we're going to end up with negative 2y and 3y is just y plus 8 equals 6. Subtract 8 from both sides and we get y equals negative 2. So now I have part of my answer. I'm going to go back in and plug that in here. So I have x minus negative 2 equals negative 4. This is the same as x plus 2 equals negative 4. And so I'm going to subtract 2 from both sides and get x equals negative 6. So now I have negative 6 comma negative 2. And again, I can always check my answer, go back and put it in. If I do negative 6 times negative 2, that gives me positive 12, plus 3 times negative 2 gives me negative 6. That does in fact equal 6, so I know it works. Okay, so that's an example with 7 and 8. If you feel like you need more practice or you need another example, try doing number 9. I'm going to go ahead and tell you you're going to get a fraction there. And then number 10, I'm going to give you the answer. It's 1 comma 7. But if you show me the work for number 10, I'll give you extra credit. Okay? All right. So the next part of this is how systems of equations show up on the park. And so I wanted to for you to see these two examples. So at a clothing store, Ted bought 4 shirts and 2 ties for a total of $95. So what I see here is what I don't know is how much each shirt costs, S, and how much each tie costs. So my solutions are S and T, which are the cost of each item. Right? A cost of 1 shirt, a cost of 1 tie. And so that's what my solution is. The thing I'm solving for is S and T. And so I need to find the shirt, the price of the shirt, and the price of the tie. So anyway, we have 2 people who bought shirts and ties, and they had different shirts, numbers of shirts and ties, but they are at the same store. So the cost per one should be the same. So I'm going to write Ted's equation as 4 times the cost of a tie 4 times the cost of a shirt plus 2 times the cost of a tie gives me $95. Then my friend Steven here got 3 shirts, so 3 times the cost of a shirt plus 3 times the cost of a tie equals $84. This, therefore, is my system of equations. And so I'm looking here at which one makes the most sense and which one matches, and that's going to be B. So now that I have this system of equations, it says, well, then Linda bought 1 shirt and 2 ties. How much did she spend? In order to figure that out, I need to solve the system of equations. So if I'm doing that through substitution, I need to solve for S or T. Now looking at this, we have 95 here, and if I divide 95 divided by 4 or 2, I know I'm going to get a decimal. So to make my life easy, I'm going to use this equation to start. So 3S plus 3T equals 84, and I want to solve for just one variable first. So let's say I'm going to go ahead and solve for S first. So I'm going to do 3S equals negative 3T plus 84. And sorry, I just skipped a step and I told you not to do that, so let me go back and show you why I did that. So I'm going to subtract 3T from both sides. We get 3S equals negative 3T plus 84. And then I'm going to divide both sides by 3. Okay? And you'll get S equals negative T, right? Because 3 divided by 3 is 1. So that's just 1T. Plus 84 divided by 3 is 28. Now I have something that I can plug in. Remember, I used this equation, so I need to plug in to S in this equation. So I'm going to do 4 times negative T plus 28 plus 2T equals 95. The rest of this equation, okay? Distribute negative 4T plus, let's see, we have 4 times 4 times 28, which is going to give me 112 plus 2T equals 95. So now I can combine negative 4T and 2T is negative 2T plus 112 equals 95. Subtract 112 from both sides, and I get negative 2T equals 95 minus negative, so 95 minus 112 is going to be negative 17. Divide both sides by negative 2, and I'm going to get a positive number, which makes sense because we're talking about cost of something. It should be a positive number. So 17 divided by 2 is 8.5. So a tie is $8.50. And now that I know that, I can go back and figure out how much each shirt costs. So let's plug in the price of the tie and see how much a shirt costs. So I'm going to use this equation just because the numbers are a little bit smaller, but it doesn't matter. You could use the first equation if you wanted to. You're going to do 3S plus 3 times $8.50 equals 84. Okay, so then we get 3S plus, let's go ahead and split. Pull up my calculator. All right, so why it keeps making it so large like that. All right, so if we have now 3 times 850, we get 25 and a half equals 84. I'm going to subtract 25.5 from 84 on both sides. We'll get 3S equals 84 minus 25.5. I could have done minus answer equals 58.5. Divide that by 3, and we get 19.5. So if I divide both sides by 3, I get S equals 19.5. That's how much a shirt costs, okay? So that's how much the shirt costs. That's how much the shirt costs, and a tie costs $8.50. So now if Linda bought 2 ties, right, that's 2 times $8.50, so that's going to be $17 plus 1 shirt, $19.50, will give us our answer of, let's see, it should be $36.50. And so she spent $36.50. Okay, So that's one way for you to go ahead and figure that out, figure that answer out there. All right. So let's take a look here at the next one. So the next one is having you graph these two equations. All right. And what's tricky about this graph is in 5s across the bottom and going by 25s up and down. So I'm going to show you how I navigated that to help figure that out. So first for this one, our y-intercept is 50. So I'm starting here at 50. Okay? And now it goes up 20 over 3, but again, I'm in 5s. So what I did to navigate that is I took 20 over 3 and divided or multiplied both the top and the bottom by 5, because that's 5 over 5 is 1, so we're just multiplying it by 1. We get 100 over 15. All right, that's an equivalent equation to 20 over 3, but it's a lot more helpful for me to go up 100 and over 15. Up 100 and over 15. Okay, so that's why I did that. Now the next one says that the other equation is 10x. In this case, that means that it's going through the origin. Our y-intercept is 0 here. So we're starting down here. And we're going up 10 over 1. So that's our slope there. But that is also not very helpful because I don't have 1s here. So I'm again going to multiply the whole thing by 5 and get 50 over 5. And that will help me to then say, okay, I'm going to go up 50 over 5. Up 50 over 5. Up 50, let me use a different color actually. Let's do blue. So here, up 50 over 5, up 50 over 5. And we see already this is where they intersect. Up 50 over 5, up 50 over 5, and so forth and so on. And so now you can see, if I were to draw my line here, and then draw my pink line to connect these other dots here, this is where they're going to intersect there. And so it says, how many items must the company sell to break even? And remember, the break even point is where the cost and revenue equations intersect. So that's right here. So the break even point would be at 15 items, then $150. So 15 items. The question doesn't ask about the $150. It just asks about the items. So 15 items. All right. That's your homework review. If you have any questions, feel free to reach out to me and let me know that you have a question. Today's code word will be bow tie. Bow tie is your code word. Happy homeworking and see you on Monday.